Hello and Assalamualaikum warahmatullahi wabarakatuh. In this video, me and the others group members will be presenting MAT272 group project video which entitled Work, Energy and Power. Our group consists of me, Nur Syamimah Atira binti Khairi Suhairi. My metric number is 0202852884. The next member is Nur Jacinta Junira binti Luqman Al-Hakim. Her metric number is 0202877252. Third member is Nur Ashiqah binti Mahdi. Her metric number is 0202478098. And the last member is Nur Adila Nadia binti Cik Norshan. Her metric number is 0202811682. So now let me introduce you guys about work. What is work? Work is a scalar quantity and is defined as the product of an applied force and the displacement of an object in the direction of the applied force. The formula of work is F multiplied by S, where F is a force, S is displacement in meters, and the unit of work is joule or Newton meter. In the other side, this is the formula when the applied force of an object and the direction of the movement of the object is not seen. So the formula is W equal to F cos theta multiplied by displacement. However, there are some times where no work is done in the particular activities. For example, a person is pushing the wall. There is no work is done here because the object is stationary. The next situation is a satellite orbiting in space. No work is done here because no force applied here. And the last one is a man is carrying a bag while walking. So here there's no work done because direction of motion is perpendicular to applied force. Next, we go through to the next component, which is energy. Energy is defined as the capacity of a system to do work. When work is done, the energy is transferred from an object to another. The amount of work done is equal to the amount of energy transferred. There are two types of mechanical energy. The first one is a kinetic energy. Kinetic energy is ability to do work by virtue of having speed. For example, is a speeding car. The formula of kinetic energy is kinetic energy equal to 1/2 mv squared, where m is the mass and v is the velocity. The second one is potential energy. Potential energy is ability to do work by virtue of position or condition. For example, a stretch bow. The formula of potential energy is potential energy equal to mgh, where m is the mass, g is the gravity, and h is the height. The last component of the introduction is power. Power is defined as the amount of energy used or transferred in a certain amount of time. Power is measure of the rate of which work is being done. If 1 joule of work is done in 1 second, the rate of working is 1 watt. The formula of power is power equal to work done divided by time.
Next, I will explain to you guys about work. Work is a scalar quantity and is defined as the product of an applied force and the displacement of an object in the direction of the applied force. In other words, action will be called work done if and only if a force has been exerted on the body and the body has been moved to a certain displacement as a result of the exerted force. There are many conditions and situations in which we will say that work is done because of our real life experience. But in the world of physics, that certain activities may not be called work done because it will not satisfy the conditions of getting work done, like applying force and displacement. Also, it is important to note that if there is no displacement, then consequently there will be no work done. If a very large force has been applied to an object and regardless of the fact that the force is very large, the object does not move or say does have any displacement, in such a case, according to physics, there is no work done. For the first example, Hazi uses a force of 80 Newton to pull a luggage along a straight corridor. The applied force is at an angle of 40 degrees with the horizontal flow. Calculate the work done by him after pulling the luggage at a distance of 60 meters. So here we can use work done formula, which is W equal to F cos theta multiplied by S to solve the problem, and at the end we will get 3,677 joule work has been done by Hazi. Next is what are work against friction and work against gravity. If there is no motion produced in the body, the work becomes zero. We can do work against gravity or against friction. When we lift something, then it is work done against gravity, and when we slide something, then it is work done against friction. The work done by gravity does not affected by friction because the work done by gravity is equal to the work done against friction plus the change in the kinetic energy. For the next example, a particle of mass 5 kg is pulled 8 meters up a rough plane incline at an angle of 60 degrees to the horizontal. The coefficient of friction between the plane and the particle is 0.3. A. Find the work done against gravity, and B. Find the work done against friction. So A, to find the work done against gravity, we can use the formula of work done as usual, which is W equal to force multiplied by vertical distance to solve the problem, and at the end we will get 339.83 joule. So next for B, we need to find R first before proceed to solve for F. After finding F, we can use the formula of work done as usual, which is F multiplied by S, and at the end we will get 78.48 joule.
Energy is the capacity of system to do work. There are two types of mechanical energy, which is kinetic energy and potential energy. Kinetic energy is ability to do by virtue of having speed, while potential energy is ability to do work by virtue of position or condition. Kinetic energy is the energy of motion. An object has a motion, whether it is vertical or horizontal motion, has kinetic energy. There are many forms of kinetic energy. It is vertibrational, the energy due to revolution motion; rotational, the energy due to rotational motion; and translational is location, the energy due to the motion from one location to another. To keep the matter simple, we will focus upon translational kinetic energy. The amount of translational kinetic energy from here on to the phrase kinetic energy will refer to translational kinetic energy. That is, objects depend upon two variables, which is the mass and the object, and of the object and the speed. The following equation is used to represent the kinetic energy Ek of the object. Ek is equal to 0.5 mv square, where m is mass and v is the speed of the object. The equation reveals that the kinetic energy of an object is directly proportional to the square of its speed. Kinetic energy is a scalar quantity. It does not have direction. The standard metric unit of measurement of kinetic energy is the joule, as might be by the above equation 1 joule. Let's discuss simple question on kinetic energy. Missy, the writer of the former platform diver of the Ringley Brothers Circus, had a kinetic energy 12,000 joule just prior to hitting the bucket of water. If Missy mass is 40 kg, then what is her speed? So, the formula of kinetic energy is Ek equal to 0.5 times mv square.
Next, substitute the value of energy and mass into the formula respectively. Then we will get the speed of her speed, which is 24.5 joule. An object can store energy as the result of its position. For example, the heavy ball of demolition machine is storing energy when it is held at the average position. This stored energy of position referred to as potential energy. Similarly, a drowned boat is able to store energy as the result of its position. When assuming its usual position, when it is not drowned, there is no energy stored in the boat. Yet, its position is altered from its usual equilibrium position. The boat is able to store energy to virtue of its position. The stored energy of position is referred to as potential energy. Potential energy is stored energy position possessed by an object. The formula of potential energy is equal to mgh. For more understanding, let's go through for the example. A mass of 2 kg is taken from the ground to the height of 10 meters. Find the potential energy of the object. So substitute the mass and height into the equation, and also substitute the gravity, which is constant, that is 9.81. So the potential energy is 196.2 joule.
Power can be applied to measure the rate at which work is being done. It is the work done in unit time. The SI unit of power is watt, which is joules per second. Use G equal to 9.81 ms power -2. The question is, a crane lifts a heavy bucket to a height of 3.5 meters from the ground in 4.0 seconds. Calculate the power generated by the crane in lifting the bucket if the mass of the bucket is 900 kg. The solution is power equal to mgh per T equal to 900 multiplied with 9.81 multiplied with 3.5 per 4.0 equal to 7,725.38 watts. The conclusion is, when the applied force on an object and the direction of movement of the object are not the same, then the work done can be calculated by work equal to force multiplied with cos theta and multiplied with time. There are two types of mechanical energy, which are kinetic energy and potential energy. Energy also can exist in many forms. The power can be obtained from dividing the work that the object has done by the time